In this video, we are going to compute the limit as x approaches 0 of sine of 2x over x. So first, I see that there's a 2x in sine, but only an x in the denominator, so I'm not sure how to do any sort of substitution. So first, what I'll do is multiply the numerator and denominator by 2. By multiplying by 2 over 2, I'm basically multiplying by 1, so I'm not changing the value of this fraction. And so this is equal to the limit as x approaches 0 of 2 times sine of 2x all over 2x. So now I see I have a 2x in sine and a 2x in the denominator, and maybe I can do some substitution. So first I'll factor out the 2 in the numerator outside of the limit. So I now have 2 times the limit as x approaches 0 of sine of 2x over 2x. And so I can do the following substitution. Let t equal 2x, and notice that t goes to 0 as x goes to 0. So now, doing my substitution, I'll rewrite the above as 2 times the limit as t goes to 0 of sine of t over t. Great. But now, if I try to plug in 0 into my numerator and denominator, I get that I'm dividing by 0, which is not allowed. So I'm going to need to use L'Hopital's rule, which tells us that the limit as x approaches c of f of x over g of x is equal to the limit as x approaches c of f prime of x over g prime of x. So it's equal to the limit of the derivative of my top function over the derivative of my bottom function. So applying L'Hopital's rule, this is equal to the derivative of sine, which is cosine, and the derivative of t, which is 1. Great. Now by plugging in 0, I can evaluate the limit as 2 times, cosine of 0 over 1, which is equal to 2 times 1 over 1, which is just 2. So we have successfully evaluated this limit.